A line L1 has equation, a line L2 passing through the origin intersects L1 and is perpendicular to L1. Find the vector equation OL2. The situation looks like this. There is a line L1, there is a line L2 passing through the origin. Point O. Let they meet at point P and these lines are perpendicular. And what is a vector equation? We need a position vector of any point on the line L2. It may be origin 0, 0, 0 plus some parameter and direction vector of the line L2, and we need to actually find the direction vector of the line L2. And how to find it? We can see that point P, as any point on the line L1, has coordinates -5 minus lambda, -3 plus 2 lambda, and 2 plus 2 lambda, and we can set a vector OP, and coordinates of any vector it has coordinates which are equal coordinates of endpoint minus coordinates of the initial of the starting point. So since starting point it's origin 0, 0, 0, vector OP has coordinates -5 minus lambda minus 0, -3 plus 2 lambda minus 0, and 2 plus 2 lambda minus 0. And if we know lambda, if we find lambda, hence we will know vector OP, and hence we will know required direction vector. We know that OP is perpendicular to the line L1, and line L1 has direction vector, and direction vector has coordinates, let it be B1, has coordinates -1, 2, 2, and we can see that vector OP is perpendicular to vector B1, and if two vectors are perpendicular, their dot product is equal to 0. So we can consider dot product is equal to 0 and get equation and solve for lambda. So it becomes -5 minus lambda multiplied by -1 plus -3 plus 2 lambda multiplied by 2 plus 2 plus 2 lambda multiplied by 2 is 0, and we need just solve for lambda, and 5 plus lambda minus 6 plus 4 lambda plus 4 plus 4 lambda is 0. 9 lambda plus 3 is 0, and lambda is -1/3. Also, lambda can be found if we consider distance OP as distance between 2 points, or magnitude of a vector OP, and magnitude of a vector, or it will be the same as distance between 2 points. It's the sum of squares of coordinates of vector OP, so it's -5 minus lambda squared plus -3 plus 2 lambda squared and plus 2 plus 2 lambda squared. And since OP is perpendicular to the line L1, this distance is actually distance from origin to any, in general, to any point on line L1, and since it's this distance is the shortest possible, hence consider it distance is the minimum of a function. And how to find a minimum or maximum? It means extreme point. It means that derivative at that point is equal to 0. So we can find derivative and equate it to 0. And if square root of something is minimum, hence just value under the root is also minimum. So we can consider -5 minus lambda squared plus -3 plus 2 lambda squared plus 2 plus 2 lambda squared derivative is 0 because it's a stationary point, it's minimum, and we need just find derivative. How to find derivative? You can definitely open parentheses and get quadratic equation expression finally, but now we can apply a chain rule, and function squared derivative is 2 -5 minus lambda, and multiplied by the derivative of -5 minus lambda, it's -1 plus 2 -3 plus 2 lambda, and derivative of -3 plus 2 lambda is 2, so finally it's 4, and plus 2 plus 2 lambda, and derivative of 2 plus 2 lambda is 2, so it's 4 is 0. We can divide by 2, we can divide each term by 2 and open parentheses and get 5 plus lambda minus 6 plus 4 lambda plus 4 plus 4 lambda is 0, and absolutely the same result. Lambda is -1/3. And if we know lambda, we can find vector OP, and we need direction vector. It doesn't matter the length of a vector, we need just any vector which is parallel to L2, so we can take any multiple of OP, and usually we take in whole numbers without fractions. So vector OP is -14/3, -11/3, and 4/3, and as direction vector we can take -14, -11, and 4. We can don't write zeros, and finally for L2 required vector of the line, vector equation of the line is just parameter, and -14, -11, and 4. And determine the shortest distance from the origin to L1. We can see that it's just distance OP, and it's just the magnitude of a vector OP, and it's square root of the sum of squares of the coordinates. So we can factor out 1/3, and it becomes 14 squared plus 11 squared plus 4 squared, and it is equal to 1/3 square root of 333, and it's square root of 37. And that's all for this question.